Hello everyone. In this video we are going to look at the problem sort color from LeetCode. This is a medium level problem. So according to the problem statement, we are given an array nums which comprises of n objects. These objects can be of three different colors: red, white or blue, and these colors are represented with the help of three integers. So red color is represented with 0, white is represented with 1, and blue is represented with the help of integer 2. And our goal is that we need to sort this array such that the objects of same color are adjacent to each other. And we need to write an in-place algorithm, and also we don't have to use any inbuilt library function to sort the array. So for the purpose of sorting the array, we can use any sorting algorithm. For example, insertion sort we can use, which is also an in-place algorithm, but it is not an optimal and the best solution because the time complexity of insertion sort is big of n square. But the best optimal solution for this problem is actually in place and linear also. So we are going to see that solution. So okay, so this approach is actually a two pointers approach, and it is an in place approach. So let us consider this example. Okay, so let's say we are given this array and we need to sort this array. So and we need to sort this array in place, and that too with linear time complexity. So for that purpose, what we are going to do is we will be taking three different pointers. So first pointer is the low pointer, which is pointing at the 0th index. Second pointer is mid pointer, which is again pointing at the 0th index. And the third pointer is the high pointer, which is pointing at the last index of the array. Now, and after sorting the given array, we will be having all the zeros at the beginning of the array, and all the ones will be in the mid section of the array, and all the remaining twos will be at the end of the array. So keeping this in mind, we will begin iterating through the given array, and we will be using mid pointer to iterate through the array. So in the beginning, mid is pointing to integer 2. So whenever our mid is pointing to integer 2, in this case we know that we need this 2 at the end of the array. So what we are going to do is we will swap this integer 2 with the integer pointed by the high pointer. So the high pointer serves this purpose only, which is that it tells us the position where we can put our twos which we encounter while traversing through the array. So we need to swap this 2 with the element pointed by the high pointer. And after swapping, what we are going to do is we need to decrement this high pointer by 1, and mid stays at the same position. Now in the next traversal, in the next step, this mid is now pointing to integer 0. Now whenever mid encounters an element 0, in that case we need to perform swap operation with the element pointed by the low pointer. Now in this case both mid and low are pointing at the same integer at the same position. So after swapping also things will stay the same, and after swapping the element pointed by mid and the element pointed by low pointers, we need to increment both the pointers by one step ahead. Now in the next move, again mid is pointing to 0, so again we need to swap, and as both the pointers are pointing to the same integer, after swapping also the array will stay the same, and we need to increment both the pointers by one step. Now Now our mid is pointing to integer 2. So as we already discussed, whenever we encounter integer 2, it means that we need to send this 2 at the end of the array. So we will swap this 2 with the element pointed by the high pointer. So this 2 will get swapped with 1 because high pointer we are having 1. So after swapping, we will again decrement our high pointer by 1, and mid will stay at the same position. Now mid is pointing at element 1. Whenever we encounter element 1, in that case we don't have to perform any swap operation. We will simply increment our mid pointer by 1 step. Now again mid is pointing to element 1, so we will again do nothing and simply increment our mid by 1. Now our mid is pointing to integer 0. So whenever we encounter integer 0, we have to do the same thing which we were doing when we encounter integer 2. In this case, we need to swap this integer 0 with the element pointed by the low pointer. So this 0 will get swapped with the element pointed by this low pointer. So after swapping, here we will have 1 and 0 will be swapped. 0 will come here. After performing the swap operation, we need to increment our low pointer by 1 and mid pointer will also be incremented by 1. So now we can see that our array is now sorted. And now how do we know that now we can stop the process? Now we don't need to iterate further, because we can clearly see that mid has exceeded the high pointer. So whenever mid becomes greater than the high pointer, we can break out of the loop. Why? Because we know that all the elements to the right of the high pointer are only 2's, and in that case we are sure that we don't have to perform any swap operations because all the elements are 2's only. So that's why we can break out of the loop, and the resulting array will be the sorted array, which is the required task. So this approach is based on 2 pointers approach, and we are using 3 pointers here. So the time complexity of this approach is big O of n, where n is the size of the given array, and the space complexity is constant because we are not using any external space. So, and this is the optimal approach to solve this problem. Now let's see the code to this question. So this is the code. So we are given the array nums, which comprises of objects of different colors, 3 different colors. So we have taken 3 pointers, low, mid, and high. Low and mid are pointing at index 0, and high is initialized to the last index. Now we are going to traverse through the array until our mid becomes greater than high. And now if the element pointed by the mid pointer is equals to 2, then we are going to swap that element with the element pointed by the high pointer. Okay. So I will repeat. So whenever the element, so if the element pointed by the mid pointer is 2, then what we were doing is we were swapping it with the element pointed by the high pointer. So in this line we are performing the swap operation, and then we were decrementing the high pointer. Else if the element pointed by the mid pointer is 1, then in that case we were not performing any swap operation. We were simply incrementing our mid. And the last case is if the element is 0, which is pointed by the mid pointer, then we were swapping that element with the element pointed by the low pointer, and after swapping we need to increment the low pointer, and we will increment the mid pointer as well. So, and we will break out of the loop as soon as mid becomes greater than high pointer, and we don't need to return anything. This will yield the sorted array. So, and if I try to submit this, so yeah, it got accepted. So this is it for this video. Thank you.